Okey doke. Well, hopefully Annabelle will be joining us soon. I talked to her this morning, so it's not like she's forgotten or anything like that. But, well, I don't know. If she's like me, she could have forgotten by now. But Project 2 is still causing some questions, and then other question. It looks like the Markov chain maybe is fine. Have you two tried that?
I haven't tried it yet, but I mean, from what you said, it's just changing those parameters around, right, to get it.
Well, yeah, it's just changing those, but is it going to work, right?
Right.
But it appears I can get the Markov chain to match the Texas data pretty quickly. Now, part of the quickly is it runs much faster so than the other. Not so sure I can get the simulation, the Monte Carlo simulation, to match the Texas data. Part of the problem is it takes a long time to run that sucker. Okay, so I thought I'd just start by talking about that a little bit and what I think, well, one thing I did do, and then what I think I might do if I wanted to try to get at this a little more. One thing I did do, where am I? Here we go. So I changed the number of experiments from 30 to 5 just so it would run a little quicker, and I guess theoretically about 6 times faster. So I, that's something I just did to try to change that. So, and right now, the last thing I ran with those 5. Now, the reason I went to 5 is the code is printing out the 5-number summary. And so I kind of figure, well, it will compute it. I mean, if I go to 4 or 3 or 2 or even 1, it should compute it. I haven't tried it, but I think it would still run. But I thought, well, it's given me a 5-number summary. I could run it 5 times and kind of see the 5 different answers here, and kind of see how much they're different from each other. And actually, the few times I've run it, they don't look that different. Oh, you're here! Yay! Okay.
Sorry.
Yeah. All right. So, and you're hearing me all right then, it sounds like, and all that. And I am recording. I tried that last time, but I had a technical issue. Anyway, I'll go back to the Sage. So yeah, we're talking. Annabelle had a question about this. And so, yeah, Annabelle, I just got through saying, I took this number of experiments and I just made it 5 instead of 30 just so I could run it faster. And if I think I have the answer, I can always push it back up to 30, just to kind of check. Other things, Annabelle and I talked about, like the days or the duration. The thing with the duration is if we want to relate it to COVID, actually, since we're trying to match the Texas data. Whatever that is, it should mean about 2 weeks. Maybe 3 weeks, but you know, it looks like, just when you look at things, if you're going to pick an average number, it probably should be about 2 weeks. So right now I've got it set to a 3, and so that means that's around 5 days. Okay, so 1 unit is 5 days. Okay, so when I look at this down here and I see that the duration was in the low 40s for the most part, actually the duration is great. Because if you look at the Texas data, the duration's about 200 days. And so if each unit is 5 days, that looks great. But I tried making my groups smaller, right? But 1 is the smallest number I could use. So that was part of the reason I went to just 5 experiments. I took this all the way up to n equal 5,000. And when I did that, this thing's still up around 2,500, 2,200, I guess, from here, from the max infected things. So 2,300. So about half, whereas the Texas data, their model that they're trying to fit it to, they had it about 1/4 of the population. So that's way too big. Now the question is, well, can I do anything about it? I don't know, right? So here's another thought I have, kind of a general notion for this. Let me go back to the board here. Okay, so for a given n, right, so if I put n back at 1,000, and I fix D at something, you know, 2, 3, 4, whatever. So I'll just call it 2 since that's what it started at. The other 2 things we have are the G and the P. G and P. And so that was a 1, and I think that was maybe around 0.6 or something like that. I could take any 2 of these, and I'd like to take these 2. However, it may possibly make more sense to take these 2 or those 2. But I think since the probability of infection is really easy to work with, I would probably make that one paired with any one of these others. Now here's where I'm going with this. So there's P, and let's try G. Now again, the way I actually may have to get at G is upping the population, you know. So from 1 in 1,000 to 1 in 2,000 to 1 in 3,000 or something. So, you know, those 2 I think are very related. And, you know, if I talk about G here, I could be talking about N. It depends on what direction G has to go. My guess is it needs to get smaller when you think about what we're trying to model, right? There are too many people getting infected at one time. Well, G is kind of telling us how many people you're around. And so if you're around fewer, there should be fewer infections. And you can always check that, right? You know, you can look at that for these quantities. But if you think of these as variables, and we've got a function of 2 variables, and see this calculus 3, it does come up, right? You know, so I've got a function of 2 variables, And I could go to a function of 3 variables or all 4 variables. It's just, you can't draw it very well, right? You know. So I got this function of 2 variables, and I could look at sort of, you know, I could try a bunch of different values here for P and some different values for G. Okay, and I'll get a few different, actually a couple different functions. I could get the duration of the whole thing. That doesn't look really hard to get at, but the maximum number of infected kind of does. So, you know, I could, for these, you know, and I like I say, I could do something for maximum infected, but I could also do a chart like this for the duration of the event. But so what I picture is I could run a few of these with these different values, right? And I'll get answers for these cases. And what I certainly hope is that some might be too big and some might be too small for my maximum infected, right? I'd like that to be a 4th. And so, you know, what I might hope is, oh, this is like a 5th, you know, but what I might see here, by the time I get there, it's a 3rd and it's a 3rd. Ah, a 4th is somewhere in between there, right? So what I'm kind of thinking of is possibly, you know, I could get contours of what this looks like. And then, oh, okay, I need stuff in there maybe. Does that make sense to everybody? Right? You know, is that now you have to be systematic about it and that sort of thing. But now something I haven't tried specifically for this. I mean, I've run more than one thing at a time. But so how might I do this? Well, what I could do is, you know, here I'm in a Sage cell for this thing, right? And so I could, let's see, Science Direct article. So I could open up multiple of these. I'll open up a total of 4, right? So I have 4 Sage cells, right? But I could actually open up 9, I think, or something like that, right? And I could pick my values. And so I'm just gonna, in this case, I'm gonna start here, and I'm gonna drop this back down to 1,000, just to hopefully have it go a little quicker. And in this case, I'm just going to pick a particular duration and sort of think of it as doing a column on of the P's. You know, so different. Column. A row, the p-value is going to change, right? The probability. I'm going to change that on these 4. And so I'm going to set that at 1,000. We'll leave the d as 3. And here I have a probability of 0.6. Well, I can try a probability of, say, 0.3, 0.4, 0.5, and 0.6. Right? So I will just take this whole thing and copy it, and then paste it in here, paste it in here, and paste it in here. And so this one I'll make my 0.5. And here I'll do a 0.4. But I think, right, because this is actually, this is processing on a different, it's processing in the server. It's not processing on my computer, I don't think, right? So I can say evaluate, go to the next one, evaluate, go to the next one, evaluate. And of course, that one I've already run, so I don't have to redo that one. But so I can very quickly, I hope, I mean, relatively speaking, right, I can do 4 runs at once in an organized fashion. Okay, and in essence, I had to do that one time. With a model, I think I mentioned that model. The function was a simulation, so very similar to this. The function was a simulation. We really weren't sure of the answer. And so the way we decided we could get the answer was for any given set of parameters we were trying to optimize over, we would just start with 6 different starting locations and let the thing run and look to see how many of those ended up with essentially the same solution. And if it was the lowest solution, we began to get confidence that that was a really good way to do this. Okay, and so this is a similar idea. In this case, each time we run it, we're getting our multiple answers, and so that's that part of the confidence. And but it's a simulation, so to really evaluate the function, I have to run it with the different values of p. And okay, so that one ran. And wow, that's amazing. So one thing I noticed there with the 0.3 is I got really different answers for those 5. So it kind of looks to me like this simulation for that low probability doesn't do that well in the sense of repeatability, right? I really would have to run lots of examples. Also, I did lower it back down to 1,000, so bringing the total population down also probably helps with the variability. But notice, I got that one done. That last one must have been one of these, right? Maximum infected was 1. So that's the picture. But as I look, though, again, vastly different, okay, for maximum infected. Now, again, that may simply be because I'm using 1,000 as opposed to, say, 5,000. And it doesn't have enough time to run. But nonetheless, I get some answers, not great ones there. And so here's the 0.5. And that's starting to look better as far as repeatability and that sort of thing. The bottom number is still very low, but the median looks more in the middle of the rest of the stuff. And so here, maximum infected was 329 for the median, and I really would have liked it to be 250-ish, 240, 260, somewhere in there. So that still seems a little high. This one, now actually I don't remember, did I run that for 1,000 or was that 5,000 and I changed it? So let's see, let's look. maximum, oh yeah, see, so I never ran that for 1,000. Let me do that. I'll go ahead and hit evaluate on that. I forgot that I had changed that number, so but with just 1,000 and just 5 experiments, shouldn't take quite as long to run. But, so you see, switching back to the board here, oh, well, there's an answer. So this one, right, maximum infected was nearly a half. And so, you know, I'm seeing that at least with that combination of D equal 3, and by the time I get up to a probability of 0.5 or 0.6, it's probably too high. You know, so in terms of what I have over here, you know, I could start filling some things in. So like if that's 0.6, and that's 0.5 and 0.4 and 0.3, and this is maybe 3 here for, oh wait, I'm doing, we'll call it D for 3 in this case, because that's just a little quicker, easier to change if I want to. But what I see is, you know, here I got about a half, here was about a third, and here I'm not so sure, right? You know, not so sure. But it does look like that if I do come down here to 0.4, that might be the right idea. Okay, but I probably want to fill in some more things, and you know, now that I've kind of come up with a technique that I could get more, you know, in the same amount of time, I could get more information, I might want to go ahead and upend to like 5,000 or something like that, because then I could run a whole bunch of cases at once, you know, maybe as many as 6 or 8 cases at once, and start filling this in to get an idea of what the answer, you know, where I should look for an answer, if I think I can even find one. Does that make sense? You know, it's kind of it's a more structured way to go about trying to find that answer. You know, but it definitely looks like, you know, I'd have to fill in some other things here. And like I say, I might change that n to a 5,000. And now here's a question that I don't know the answer to. I haven't tried it with this model. Is suppose I change that to 5,000 and I change G to a 5. Do I get pretty much the same result? Oh, good question. Right? And I could try that again using sort of this simultaneous technique of opening a few of these windows. I could try a G of 1 and an N of 1,000, a G of 2 and an N of 2,000, and just kind of go and see, you know, sort of theoretically, they should mean about the same thing, but there is a difference, right? You know, if I see 1/1000th of the population, you know, okay, that's fine. But again, we're still starting out with one infected person. So if we have a bigger population, it does seem reasonable it could be slower to get started. Now, once you're really into it, I would think there's not really that much difference. So I might expect that if I leave these two the same, D and P, and I keep the same ratio here between N and G, I think there's a reasonable chance that the maximum infected won't be that much different. But I could be very wrong, okay? You know, so but you can set up these grids and you can open up a bunch of these windows to just try more numbers at a time. And in doing so, you might decide that you can't really get this model to fit the Texas data. Oh, okay. Well, there's an answer, all right? That it looks good. I mean, it's got the right shape and all that, and it might fit some other infection really well, but it may not fit the coronavirus and COVID-19 that well. Okay, does that help with that one? Is that, Annabelle, does that help you with that kind of question on that?
Yeah.
Yeah, okay. So then, I think the other big question is, well, actually I'm not sure exactly what Christian's questions are on the Project 2, but there definitely seem to be plenty of questions on Project 2. Let me go here. One question was, is there a template for the SAGE? And so here, this is in the instructional content of Module 2. There is this solving LPs with Python and Sage Cell, and it has a code here for an assignment problem, and a video of me going through and solving one. And so this was with the Python and the SciPy optimize and linear programming and all that. Now, another possibility that could be easier, I don't know, I haven't done enough work with it myself to know whether it could be easier, but within Sage, they do have, this is also a Python routine, but they do have this convex optimization thing, and it does look reasonably easy to use. So if you come all the way to the bottom, it has one example of a simple linear programming problem. Now here, they have, it's minimize and let's see. 1, 2, 0, -1. Yeah, okay. So the question is, oh, okay. I don't know if that's, let me look back here, because there was also a Sage. That's that thing, that's that one. Those are all the ones I opened. Oh, I got a bunch more over this direction. Oh, okay, yeah, so I hadn't noticed that. All right, so here's the actual Cvx Opt Users Guide. And they say what you can do is you can solve a problem like this one. Let me make that a little bit bigger. So we can solve a problem like this where we want to minimize something times x, subject to, now the G plus S, that is just the inequality constraints, but I hadn't noticed that they actually put them in that way. Okay, so in that way, this could be a little rougher than doing just the Python, since all we're doing is linear programming. And then here they had that the slack variables had to be greater than or equal to 0. And so as I look at this, yeah, what I see being a little bit of a problem here is if you want to put bounds on your variables, like 0, 1 variables, that's what we have, 0, 1 variables, that might be a little harder in here. Now, though, again, this thing back here somewhere, let me get rid of these sages here. All but one of them. So we're back here. So if I click on that, it opens up and so we can see that. Let me make that a bit bigger. So for this particular template, what you do is you put in, for your equality constraints, all you have to do is put in the coefficients, and you can put them in as integers. I mean, you don't have to put point after each one. So I think this one is probably the easiest to enter things. And then you have to, you can, or well, I think you have to put bounds on your variables. Now they can be infinity, but there's probably the easiest way to do it, is you just do a lot of copy and paste of zeros and ones. So, this shows me how to do my equality constraints. Again, one row at a time, I put the brackets around it. Here are the objective function values, and they're just in a big list, so that's not bad. The right-hand side of the equalities is here, and they were all 1 in an assignment problem. So that was there. And now this stuff is all commented out because I felt that's how they, I think, showed it in the help that I looked at. But that's cumbersome, I think. I mean, it's much easier to put those bounds up here this way. At least I think it is. And so then, now this is also commented, so this isn't really there. You could get rid of all of that stuff, and that would include that. Whoops, missed it. But anyway, all that stuff. And here's the result, and it says show the result. So, I can take this and copy it and go to one of my Sage cells here. I'm going to go ahead and, so I tried that one out and it gave me an answer and said the optimal solution was fine. But actually, I'm not even exactly sure how to interpret that answer. I hadn't looked that far. So if I put all that in there, notice how, now that's all one line and it's commented out. I ask it to evaluate. And this, I think, is a much friendlier output as well. You have to read about it, but the constraints, it's looking at how much slack there is, but these were all equality, so there shouldn't be any. It said optimization terminated successfully. Number of iterations was 27. The function value I got was 131. And the answer is 0, 1, 0, 0, 0, 1, 1, 0, 0, right? So it's pretty nice to use that way. Now, I think if we look at this, let's see, this is an equality constraint. equality constraint, equality constraint, equality constraint. Yeah, so all the constraints are equality constraints. So the question is, can you write those down and get their coefficients, right? That's what you need, is to come up with coefficients. And so, and like I say, if I have the coefficients, so here's maximize this. So for the given data, I actually have to calculate that thing. And those are the coefficients on the B variables. Now here's the thing, you have to remember there are other variables, right? So you have to decide what order you're going to put your variables in. And write them all, what you want to do is write them all out. And it is tedious, okay, but that's sort of by design. I wanted you to have something that was tedious enough that you had to sit there and go through it a few times to get all the stuff. But once you write it all down, once you kind of do that, hopefully you'll get this idea a lot better through that repetition. Okay, now, so questions on finding these coefficients or writing down what these things are. I see a yes nod there.
Yeah. Okay, you said
Yep.
that in task 1.8 that putting in the values for that one and solving that out, that would give you the coefficients for the B part?
Yep. Well, so for, whoops, where are we? I'll get back there someday. Here we go. Right, so somewhere, where's the data? Is it above or below this?
I think it's below.
Below, okay. Yeah, so this is where you decide, hey, this guy's not such an a-hole after all. He only gave us 5 epochs, right? So when I solved this, it was for 30 days, and I had to go through and kind of figure out what the coefficients were, and so for 30 friggin' days. It was rough, and but this is just 5, right? And so we have the price of the stock for each of those 5, and so when I come back up here for these cost coefficients, right, I need to think about, okay, it says I equals 1 to n minus 1, and j equals I plus 1 to n of these things. Okay, now, what the heck was that again? And that was all my possible buy-sell things, right? My buy-sell combinations. And so, let's go back to the board. Okay, so we had 5 things, right? So I start, and then I can, one of the things I could do, and I said argue that, for that one, just call it, I'm just missing everything, right? I'm not going to do a darn thing. Okay, but the others, so I could buy here, and that was like 385. That's the only one I remember, but but that was like 385, and then I had, well, kind of running out of room, but these 5. Okay, and then I could sell. I could buy here and I could sell there. Okay, and I could sell there, there, and I think I need to add another circle down at the bottom of this, so I could buy here and then sell it. But so, this is I equal 1, here is I equal 2, I equal 3, I equal 4, and I equal 5. And so as I'm trying to get a coefficient, so this would be B12, right? So I need a coefficient for B12. And here, I guess, you know, I don't know what this next one is, but let's say it's 386 or something.
I think it's 366.
Oh, 366. Woo! Not selling then. Okay, so 366. And so what that says is the coefficient on that B12 is I got to go back here and look real quick. It is the log of the j over the I. Okay, so in a minus. Okay, so let me go back here. So that coefficient for that thing is the natural log of 366 minus minus $1?
Yeah.
Is that what it, yeah. So minus 1, and this one's 385 plus 1. Is that making sense? Right? Because I paid the 385 plus $1 per share on that one, and then sold it for 366 plus $1 per share, which took away from my money, right? So it's kind of funny how the pluses and minuses work there, but one was, remember this one being in the numerator, that one being in the denominator, right? A plus 1 here hurts me, and a minus 1 up there hurts me. Okay, so so that's my coefficient. I would call that like C12, I guess, right? Now I got to be careful because there are lots of 1s and 2s and stuff running around. But then, you know, I would have this possibility, and you know, and actually, now that I look at this B12, can I do that? I don't remember the rules exactly. Can I, because I guess I'm back to cash. So if I sold it, I bought it in 1, does the little arrow stuff show I can sell it then at 2, or do I have to wait till 3? I don't remember. So this says, okay, this says I can make J just 1 bigger than I. Okay, so that's good. Let's go back to this sort of thing. Sell there. Oh, okay, so, and then the way I come back is I would come back whenever I bought again. That's where I was just, I couldn't remember, I hadn't looked at it for a little bit here. So you see, I buy here, I sell there, that's perfectly fine, but I couldn't get back to here until the third one. And that's what I was thinking about, was I can't get back to buy something again until 3. Okay, so buying in 1, selling in 2 is fine, but if I do that, I can't buy anything in 2. I could only buy in 3. Okay, so, all right, and okay, so this would be the B12, this would be the B13, you know, and that has a particular cost to it, and I could come up with that coefficient. Let me put an equal sign there. Okay, so that's how I'm going to come up with my coefficients, and I need coefficients for each of those possibilities along with each of these possibilities. Okay, so I've got four variables here,
Wouldn't it be 5?
and then 3 variables here, and then 2 variables here, and 1 variable here. So yeah, I guess I don't need that because I wouldn't come back. Yeah, so that's it's all coming back to me now. So I'd have 2 coming out here and just 1 coming out there. So that's 4, 3, 2, and 1. That's 10 buy-sell possibilities. Okay, so I should have 10 of these coefficients.
I have a question.
Yep.
Okay, so it gave us 5 numbers, and at first you said that you lost room to put 5 on the yes, right-hand side.
Well, actually, yeah, we end up with sort of, I think 4 on each side, or let's go back and look at the picture again, because I'm pretty sure of that picture. Yeah, see, there's n minus 1 on the left-hand side. So,
Okay.
see, the last time we could buy and then sell is actually the n minus 1 spot, right? Because if I buy, I can't buy on the last day, as it turns out, unless I put in a fictitious. Now, I could put in a fictitious 6th day, or, you know, that's the day that I do have to have everything sold by. And, you know, that could be this n down here. But notice, you know, they're the same number on the left as on the right. It's just that they're shifted by 1. Okay? So if we go with, and I'm fine with, I mean, by the time you do 4 of these, you could have done 5 of them, right? You know, I mean, so do 4 of them, right? You know, and so you'll get down to that. Well, let me go back up here, where down. It's one of these directions where the data are. So really, your last, oops, probably making somebody dizzy. Okay, so so really, you'll only worry about these prices here, I think. The 362, well, I guess the 362 still does come in because that would be the day you sold it, right? So you have all of those prices, but it ends up being just 10 of these variables. Okay, and so let's, you know, list them out real quick and make sure that we've got that, right? I can buy in 1, sell in 2. I could buy in 1, sell in 3, buy in 1, sell in 4, or buy in 1 and sell in 5. right? And I'll have numbers for each of those possibilities. So all of these will have the 385 on the bottom, and they'll have different numbers on top. And then, I could buy in 2 and sell in 3, buy in 2 and sell in 4, buy in 2 and sell in 5. So there are my 3 possibilities there. Buy in 3, sell in 4, buy in 3, sell in 5, and then finally buy in 4, sell in 5. But I'll never actually buy in 5. So I need its price, because that'll be in the numerator up here for each of these 5s. Okay, that's where that price comes in, but it'll never be in the denominator, because I'll never buy in 5.
So in the code, when you get these coefficients, where are we plugging these in again?
Okay, so C is the coefficients.
Okay.
And so as we look at this, we need to make sure we've got all our variables. So we mentioned 10 of the Bij, so there's 10 variables. We also have I think I've got a typo here in equation 4, because you see that says the sum I equals 1 to n minus 1 of x0. Should say xi, right? And actually, well, it should be I equals 0 to n minus 1, because we do need the possibility that we never buy anything. We just keep our money. And so, yeah, that's a typo. That should say 0 to n minus 1 in that equation 4, and that should be xi.
Okay. Would it be n plus 1 then? Well, no, that wouldn't make sense.
No, it's I equals 0. I mean, because that's what we named it as we talked about it, was x sub 0. And so that's all our starting possibilities. One of them has to be true, and that's all that's saying. Okay, so we've got the x variables though. So our n is 5, and we're going from 0 to 5. 0 to 4. So there's a total of 5 more variables. So we had 10, we now have 5 more. The y's are the same thing. So there's 5 more there. That's 20 variables. Okay, so every thing that has a row so far needs 20 slots. And then we need the sj's, and let's go back to the board on how many those are, but that would be all our variables. Okay, so sj's, right, I can be here and come down to there. That's 1, 2 out of that one. And I can come back to there. That's 1. So I've got a total of 3, I think, right? Because this one, I can't go down. And so my sj's, I have a S2, and I can go back to 3, or I could have an S2 and go to 4, or I could have an S3 and go to 4. But that's just the idea of traveling back to be able to buy again. Okay, so we had 10 of these, 5 x's, 5 y's, and 3 s's. So 23 variables. So then the question is, okay, how are you going to organize them? Right? And it's really up to you. I mean, you can organize them any way you want. Okay, so I could do something like, since the x's started off, right, you know, I could kind of go from left to right, and I could say, well, there's x0, x1, x2, x3, x4. That's, you know, where I make my first buy is one of those. And then, if I wanted, I could do the b's, so the b12, the b13, and again, I could organize those within themselves. I could do b12 and then b23 and then b34, and I kind of like it this way. And then my last one is the b45. But there's a total of, you know, 10 here. There are 5 there. Then I'd probably do my S's because, you know, they're sort of next from left to right. And so I have my S23, S24, and S34. And then finally, I have my Y's. Y0, Y2, Y3, Y4, Y5. So there I could organize them that way. You know, I've got 3 slots there and 5 slots there. That's a 5. And so everything I type in for constraints, for the objective function, I need 23 spaces. And so if there's nothing there, it's a 0. So for instance, C, if I use this, C is 0, 0, 0, 0, 0. Right? Because I make nothing and any of that. Those aren't part of my objective. Just the B's are. And then I have my logarithm of this stuff, right? And logarithm of that stuff. And I do that for 10 of them. And then I have 0, 0, 0, and 0, 0, 0, 0, 0. I think 1, 2, 3, 4, 5, 6, 7, 8. Yep. And there's my coefficient matrix. Questions on that? Okay. And so then you have all the constraints and the bounds. Now the bounds on every single one of these is 0, 1. Right? Every single one of these, that's the wonderfulness of this particular formulation. Every single variable, 0, 1. And so, well, then whatever that was the bounds. I don't remember if that had 2 brackets maybe like that, and 0, 1, and then a comma, and well, I need 23 of those instead of whatever's in there. Okay, so that's fine. And then, well, there's the other stuff. Okay, so, for instance, and again, I apologize for that typo here for 4, but here are the constraints, right? So there's a constraint, and so if I've got things ordered like I do, that's all the x variables, so I should have 5 1s followed by 18 zeros. And that's my first line of the equality constraints. Does that make sense? Okay, and then the second line, I guess, you know, because I just probably go in this order. The second line would be 18 zeros and then 5 ones. And then the third line would be a 1 followed by, now the math gets hard, followed by 17 zeros, I think, and then a -1, and then 4 more zeros. Okay, because we only have the x0 and the y0 there, and the coefficient on the y0 is -1. So those aren't bad because those are one line each. Okay, and I just have to get the ones and the zeros in the right places. Then I come down here and I get to this thing. Well, now I gotta kind of think about, you know, what that is saying. So notice the I on there, it says I goes from 1 to n minus 1. So that means that's 4 rows. Okay, that's a row for each I. So I go 1, 2, 3, 4, and what it says is xi. So I'll have an x1 minus, and then it's a sum of the j's. So I is 1 though, right? I is fixed for any given row. So I'll have an x1 minus, and then I'll have the b's, so minus b12 minus b13 minus b14 and minus b15. And then plus the s's, and so the I again is fixed, it says j goes from 2 to I minus 1. Okay, so when I is 1, that would go to 0. So there's nothing there, and we should check that. Okay, and then when I is 2, it says there's nothing there. Okay, and then when I is 3, we can actually do, it says, a 2, oh, well, yeah, wait a minute. Well, it could be a bit of confusion. Let's check that out, okay? I think that's correct, but let's look at what it's trying to model. So it's saying x1, okay? So let's switch here. And that is saying that we're going to, if it's x1, we're going to buy in the first thing there, okay? So let's go back to the board. Okay, and let me erase all this mess. And this is just saying that, okay, we start here and we decide we're going to buy here. So this is 1. Okay, and if I buy here, then I have my possibilities of I could sell in either 2, 3, 4, or 5. Okay. Now, if I sell in 2, then let's see, and the S's are, so I could come back here, that exists, and I could come back to there. This is a 3, that's a 4, and that's a 5. Okay? And, so, no. That's a 4. Try that again. Okay. So, what that was saying on there was, and so what I'm wondering is the interpretation of that sum may take a little work here. I mean, we may have to think about what it's actually saying because it's in reverse. Okay, so that said, if we start here with x1, then that plus one of these, right, has to be something. I mean, so if this is a 1, one of these has to be a 1, right? Because if we bought, we had to sell, right? So one of these has to be a 1. And that constraint, again, was, for just the one, it was x1 minus the sum of the B1j's. And this was j equal 2 in this case, up to 4, right, or 5. Was it to n or n minus 1? Yeah, so, because that would make sense that we could do that. So that has to happen. But since we bought, we also have to sell at some point, right? And we can sell, if we bought here in 2, we could sell in 3 or 4. And so this was a plus, I think. And it said j equals, this was an I minus 1, and that was a 2, right? And this was S j1, because the I is 1. And so what should this be trying to tell us? It should be trying to tell us that we could go to 3 or 4. Okay, so I could SJI? Was that an I? It had to have been, right? SJI. Sell again. Yeah, actually, I'm a little confused on this one. Yeah, you can't go back. So I think, yeah, I'm with you all that, you know, and now I apologize, and this seems last minute, but I'm going to put it back on you and say, you know, if you'd asked me about this 4 weeks ago, right? You know, so I mean, it's unfortunate, but I'm not going to take all the blame here, right? You know, so I think, yeah, that should go to from 2 to Yeah, that should be an n minus 1, I think, as you look at this, right? If I, now I'll have to go back and look at what that constraint said when it was made. Because that's the other thing, is I've been worrying about a lot of different things, and actually this hasn't been one of them, right? You know, I mean, so, yeah, it looks to me like that ought to be n minus 1. And then this should be Sj, and then okay, so this is, I bought in one and I'm selling in one of these. So if J is 2, then this ought to go from, oh, well, I think that's the problem, is if J is 2, let's see. Yeah, so J could be 2, 3, 4, or 5, I think, right? Oh, wait, no, but this is selling and going back somewhere. So, yeah, it couldn't be, it couldn't, yeah, it couldn't be 5. So, well, I mean, this could be 5, but there's no 5 there. And so, yeah, so if J is 2, so we said buy in 1, sell in 2, then we have the option of then buying again in 3, so we could come back here, or we have the option to come back to 4. And so that would be 2, 3, and 2, 4. So, yeah, I don't know. I have to go back and look at how this was made. Okay, so let's go back and look. So we're looking at this, but where did those come from? Oh, okay, well, I guess it just came from there. Linearizing profit. Well, let me make sure. So SJI is if I sell in J, if a sell in J leads to a buy in I, okay, yeah, that's, and so, okay, if that's a 1, then one of those would have to be a 1. And the amount of traffic into a buy node must equal the amount leaving. Oh, yeah, okay. See, I had to look at what it was saying that was doing. I didn't read that. You should read things. Yeah. Okay, so this is the conservation of flow idea is all it's saying. And so now I'm on top of things. Okay, so this is going into 1. Okay, oh, I need to switch to the board. Okay, so sorry about that. This constraint is correct. So I thought I was wrong, but I was mistaken. Okay, so this is going into one, this one's going out. That has to be true. That and then minus that has to be 0. And that's all this is saying. So this should be an I minus 1, I think, because it's just not going to happen. Okay, there are no SJ, so it's not really there, right? So if you were writing this constraint down, you would only have that. Okay, and then you'll have an x2 minus the sum j equals 3 up to 5 of b2j. And so I'm going to, X that out for that first one. And then 2, okay, this can go in, and it can go out there, it can go out there, it can go out there, but nothing else comes into it. So again, that doesn't exist. And so it makes total sense why that I minus 1 is too small. You can't do it, right? So it's written that way to just say, well, you can't do that one. And so x3, okay, so x3, it could go out to x4 or x5. Those are going out. And so x3 minus the sum j equals 4 to 5 of b3j. Okay, so x3 came in, and these two went out, but then this one came in, 2, 3. And so this should be plus, and this is the sum j equals 2 to 2. Ha! It works. See, I used to be smart. Okay? And that's the SJ3. And that is exactly what you want, is 2, 3. It's all coming back now. Okay. So those are just the conservation things, and you'll get the same things here. And so it's just, if you actually name this stuff, so here's the B12, B13, and so forth. Those two constraints, so let's go back to them. Those two constraints, 7 and 8, are just nodes in minus nodes out. Okay? And that's why you've got the xi's on 7, because you're looking at all the b nodes, or the buying nodes. And then you've got the y's on 8, because those are all the selling nodes. Okay, so again, going back then to this thing, so, what I would see is, here's x1 is a 1, and then I'd get a minus 1, and a minus 1, and a minus 1. I get, 4 minus 1s for the B12, B13, B14, B15. Those would all be minus 1s, right? And there would be nothing else for those, so everything else would be zeros, right? The x1 would be a 1, all the other x's are zeros, the b1s should all be negative 1s, and then everything else zeros. Second row for the x constraints, x2 should be a 1, and then all the b2 should be negative 1s, and nothing else. And then the x3 That'll be a 1. The B3s are all negative 1s, so both of them. And then a 1 on the S23. But everything else is zeros. So lots of zeros. So what you could do, right, is you could count the constraints. Okay, so we're going to have a constraint for each of these. So that's a total of 8 constraints. We had the constraint up here for going through that way. So that's 9 constraints. We had the constraint that all of these need to add to 1, so that's 10 constraints. And we have all the y's have to add to 1, because that said, yeah, we had to sell somehow. So that's, what was I up to, 10? So 11 constraints. And so I believe you'll have a matrix of 23 columns and 11 rows. And what you could do, just in a document or something, use cut and paste, you could make all zeros, right? What I might do is I might go to a spreadsheet, right, to actually make this thing. I do this sort of thing way more than you would think, okay, because of typing and all that. So this is really big. I'm going to make it actually smaller. Okay, so I would go here and list out my variables. Right, so I would have my x0, x1. Now, if this is really smart, it will, update them for me. Let's see, it was x4. Yeah. So I've got those, and I might center everything so I can see it better, right? And then I have the B12, B13, B14, and then the B1, let's see, in cell and 5, yeah, so B15, and then B23, B24, so I would do something like that. And then to make my matrix to paste in somewhere, right, I could do this. And actually, if you're really savvy with your spreadsheet, you might be able to do this in some ways even not easier than what I'm doing here, but easier than what I'm going to show you in a minute. We'll try something first and just see what happens. Okay, so now I'm going to put in 0, right? And I need, I'm going to do a Control C, and what did I say? We need 11 of those, so I'll go down to 12 and paste. And then I'll go out here and, and I'd keep going with all that, but I'm going to stop there just so we can see and paste. So see, now I got all zeros, and again, I would probably center this, everything in here, because then I can see it a lot better. So I center it, and I might make the columns narrower so I can see everything, that kind of thing. But there are all my zeros, and so one of those constraints was that, x1 and y1, so I'd need a -1 way down here somewhere. But, there's my 1, my x1 is 1, or x0 is 1, and here's the 1, and then these were all -1s, so -1, -1, and I could use copy and paste to do some of that, maybe. Okay, but there I'm making that matrix. Okay, now once I have it done, one thing that you might be able to do is, I'm going to try this, file, I'm going to save as, and we'll just put it in the top of documents here. I think that'll work. And I'm going to save it as coefficients. And I'm going to go here and actually export it to a CSV file. Okay, now why a CSV? It's a text file, and what it does, usually by default, is it saves things with commas in between them. Now, if life doesn't get any better than that, right? You know, so I'll actually sort of try to ensure that it saves it that way. So I'm going to put .csv at the end of that, and I'll say save. And it says, do you really want to do that? I say yes, and then there's that comma thing. I say okay. And now I'm going to close that and go here to Documents, and there it is. And now I'm going to open that with a text editor, so like Notepad or something, maybe even Word. And let's see, text editor. And let's just see what it did. Yeah, commas. And so now all I have to do is, if, you know, I can, on this first one, I can go with 2 of those brackets, and then put a bracket here and a comma, right? Way quicker way to put in a whole bunch of 1s and 0s and stuff. And, you know, and I can do that all the way down. So here's the next square bracket and the next square bracket and so forth. And so that's one way. Now, another way, so I'm going to undo, well, I'll just get out of here and not save. Okay, so now let me pull this back open. And, you know, to me, I think as high school graduates these days, people should know how to do this kind of stuff. You know, and they don't teach you. And I find that horrible, because we've got all these different beautiful software tools at our disposal, and if you don't use them exactly the way they were made, you can really come up with some nice ways to put things together to make your life much easier. Okay, and what time is it? 3:20. Are we like way over? We are, aren't we? But you didn't like close up shop or anything, so I guess we're doing something good here. Okay, so another thing you can do, and I resort to doing this at times because maybe I need something more complicated than a comma in between stuff or whatever. But there's nothing that says you can't insert a column and put a comma in there and copy it down. And see, now I've got commas in between, you know, and I could do that with each of these things, and I could insert a column here to the left and toss in, again, I needed kind of a double square bracket there, and then I'll need square brackets all the way down. I think I'd have to, oh, I just wanted one square bracket, quit that. And, you know, I could grab that and fill that in. And then on this end, I needed a square bracket and a comma, you know, so I put that in and I pull that all the way down. But then at the bottom, I need 2 square brackets. And then if I just highlight that whole thing and copy, and I go to a Sage cell we'll just put it all in, up at the top of this, just to, and I paste. There it is. And it's got spacing stuff in there, but I don't think that matters. And if it does matter, which I don't think it does, but if it did matter, you might paste it into a text thing like Notepad first and then try pasting it in here, but I don't think it matters. So I think it added its own spacing, of course, but I don't care. I mean, I got it. Right, and so I can use a spreadsheet to make my data entry way, way easier. Right, so there are my 11 rows, and I could put them together, you know, with my 23 columns once I did all that, and get my ones and zeros and minus ones, and take care of that. You know, the coefficient one, again, I need to get the logarithms of that, but a lot of zeros in that as well. And I could, so, you know, I could put everything in here. You know, I could even, whoops, I don't know why I did that. I just pasted all that stuff again. I hit enter. I don't know why it pasted it. Okay, so, though you could, you know, either here, you know, anywhere, it's totally up to you how you do it. But, you know, here I could put in like the coefficients for the b's, right? So that's equals logarithm of, and what did we say? I erased it. It was like 385 minus 1, and, you know, so, and that was on the bottom, I think. So it was like 366 minus 1. I need another parenthesis. And divided by 385 plus 1. You know. Close that off, hit enter, and there's my number. Now, what you probably want to do if you're going to use that, do it that way, you probably want to open it way up like that. Now, the other thing you can do, of course, is oops, I got the logarithm there. Take out the equal sign, and now it's a formula. And put the commas in between, right? And you're putting the formula in so that Sage calculates it to whatever ability it can do, right? But if you, well, and actually I've seen it behave differently on different things. Sometimes, you know, if you copied that minus 0.06, what it would copy is the full number that you have there. Other times, I have pasted into some applications where it actually seemed to take whatever it had been rounded to. I think usually it does the whole, you know, the whole number all the way out. But yeah, using the formula might be a little better than pasting the number in there. But either way will work, right? And so you can get that data entry pretty simply, really. I mean, it doesn't take that much work. You just need to write out what those constraints really are, and then make your coefficient matrix to fill it all in. And again, you know, the copy and paste stuff, you could do that right within Sage Cell. You could do it in a text editor. You could do it in a spreadsheet. But things like the bounds with the 0, 1s, well, you know, if I know I need 23, it might be better to, you know, sort of line them up with the variables, so I know I've gotten just the right number, and put the commas in between and so forth, and just fill that in with this same structure here. And get the bounds in that way. Is that making you feel better? Okay.
Yeah.
Okay.
So C, we know what that is. That's this 5 zeros for X's. The S and the Y's are zeros, and then you just plug in the natural logs for the B's.
Yeah.
And then what is the matrix going for? Is that the AE or BE?
That's the AE. Now the
Okay.
BE is the right-hand side. So you can keep track of the right-hand side, but most of them, if not all, are 0 on the right-hand side. So it would just be, you've got 11 rows, so you would have 11 zeros in a row, right? It's just the right-hand side of those equations, but the conservation of flow, oh no, the fact that you have to buy, so the sum of the x's has to be 1. So I think that was our first constraint. So that right-hand side is 1. And then our last constraint is the fact that you have to sell. So the sum of the y's is 1. And so that one's a 1, but the other 9 in between are all 0. Okay, so there's, lots of 1s and negative 1s and zeros, not a lot else other than those logarithms, those 10 logarithms we have to put in there. But really not that much when all's said and done. And what you can kind of see from this is going up to, say, 10 of these instead of 5, it's going to be quite a bit bigger. I mean, because the B variables, it's the sum from 1 to 4. If I have 5, it's the sum from 1 to 4, which is 10. Well, if I have 10, it's the sum from 1 to 9, which is, I think, 45. Yeah, 45. So, by doubling it, you get way more than double the variables. And it's more like the square. And so it does get big really fast, but using some of these, even though these are kind of hand techniques, automating them a bit with a spreadsheet and copy and paste and that sort of thing, it's not that bad. Okay, anything else anyone needs? Other questions? Okay, so I think we took care of it. If you do, just shoot me an email. Now, here's the thing. I would also like to point out that, well, we'll go back to here, so Annabelle can see my nice new fitting. I tied some knots in it. This mask was getting really loose, so I tied some knots in it, and it's a little tighter now. So, the semester ends on Wednesday. However, grades are not due for a little while. So, reasonably speaking, we do have until probably Monday the 29th. So, 10 days from now. 30, that's what I said. Yes, the 30th. Yeah, Monday the 30th. We really have that, okay, because I don't have to get grades. Now, that said, if everybody sends me everything on the 30th, that's not as good a situation, all right? But from the standpoint of stress, okay, don't stress Wednesday if you don't have to. Now, you may have a reason you need to stress Wednesday for all sorts of reasons, who knows? but don't let this class stress you that way, because yeah, really, you've got the Thanksgiving weekend. If if that's your choice, I mean, you can always, give me everything today. That's fine, but it's your choice if you wish to spread things out a little bit and not feel as stressed. Okay. Anything else?
Thank you.
On the Monte Carlo and the Markov,
Yeah?
what are we turning in? Are we just turning in the code, or are we like?
No, turn in your parameters that you think can make it work, and actually I'm pretty happy with that. You might put a few, 2 or 3 sentences with it, especially if you think it doesn't work, right? You can say, in particular, right, the Monte Carlo, if you can't make it work, I think it would be reasonable to ask you to say, hey, I tried all these things and it didn't, I could not get it to match up in a decent way. Again, though, the nice thing is you can always change what the time means, right? So the big key is whatever D is, it corresponds to 2 weeks of real time. So, D could be 1,000, in which case it's 2 1,000ths of a week, right? Or D could be 1, in which case it's 2 weeks. D could be 2, in which case then it's 1, then time is 1 week per unit. And so you can change D, is just whatever you want to then look at the duration, and the duration needs to match up with the D, right? So if D is 4, that says every 2 time units is a week, and the duration of this whole thing should be whatever we said, like 30 weeks, right? Yeah, because I think the peak was at 100 days, right? So it should be somewhere around 28 to 30 weeks, and maybe 29 weeks would actually be 100, very close to 200 days, but right in there somewhere. And so the duration, if D is 3, and that's 2 weeks, and you need 28 weeks, then you need, so 3 is 2 weeks, so you need 3 halves of 28, right? And so whatever the heck that is, 42, the duration would need to be somewhere around 42. Is that all making sense? It's just a units thing. You got to make the units match. Okay. Anything else? No? All right. Call it good.